So we see that if y of t equals at squared plus bt plus c, it follows, logically, that the depth function y prime of t has to be 2at plus b. This is a general quadratic function, and this is a formula for its derivative. The derivative, remember, gives us the rate at which the function itself changes. Now, let's go back to the depth model. Y of t equals 0.015 t squared minus 2.15 t plus 88.7, which you obtained by substituting 3 data points into the form of a quadratic and solving a bunch of simultaneous equations. We obtained this depth model. The question is, for this depth model, at the t equals 65.4 second instant, at what rate or how fast is the level changing? How are we going to answer this question? Well, we have a quadratic model. We have a formula for its derivative, or its rate of change function. So if we simply take 65.4 seconds and put it in to the rate of change function, we're probably going to get the result that we want. Let's see what that looks like. We've got y of t equals this. The general form is y of t equals at squared plus bt plus c. So we see that a is 0.015, b is negative 2.15, and c is 88.7. Y prime of t is 2at plus b. So how are we going to get 2at plus b? Well, we go back here and identify a as 0.015. So 2at is going to be 2 times 0.015 times t. And we identify b as negative 2.15. It looks like we're having a problem here again. I have to take care of that in a minute. Okay? So we put the negative 2.15 that we have for b in here where b is. And we evaluate y 0.03t minus 2.15. Now, if we go to t equals 64.5 seconds, we simply substitute 64.5 seconds into this y prime of t function. We get y prime of 64.5 equals this. And that's a very straightforward substitution, and we can do the arithmetic. We get negative 2.15, or 0.215, which incidentally has nothing to do with this negative 2.15. This is simply a very unlikely coincidence. I chose 64.5 seconds very arbitrarily, and I had no idea that this was going to happen, but that doesn't really mean anything. It's just a coincidence. Now this is really neat because we've been able to take our time and just simply plug it in here and save a lot of calculation to obtain this result.